So இன்னைக்கு very important topic, that is the inner product space. Already this is in the syllabus, college TRV syllabus, inner product space. The next topic module, அதுக்கு next topic field, continuous 3 topic உங்களுடைய college TRV syllabusல இருக்கு. So the inner product space means it's a very simple concept. The vector space V over F is said to be an inner product space if there is defined for any two vectors u comma v. Okay, the inner product space is defined, there is for any two vector u comma v, an element u comma v in F such that u comma v is equal to v comma u, the conjugate, that is the symbol is called the conjugate symmetry ன்னு சொல்லுவாங்க. And the inner product of u comma u is always positive. If in the case of greater than equal to 0, inner product of u comma v greater equal to 0, then u equal to 0, that is called the positive definiteness அப்படின்னு சொல்லுவாங்க. And alpha u plus beta v comma w, the inner product of alpha u plus beta v comma w, that is we can express alpha times u comma w plus beta times v comma w, that is linearity in the first argument அப்படின்னு சொல்லுவாங்க. The first argument, first linearity property, that is for any u v w belongs to v and alpha comma beta belongs to f, alpha comma beta belongs to f. And the example for the inner product space, the R power n, the vector space R power n with inner product defined by inner product of x comma y outer defined, that is x1 y1 x2 y2 plus x2 y2 plus and so on plus x and yn. So here x is called n tuples, y is also n tuples, that is x1 x2 xn, y equal to y1 y2 yn is an inner product space over the field R. These are satisfy that properties. The first property conjugate, and second property positive definiteness, and the third property the linearity in the first ordinate. Okay. The 3 properties should be satisfied. Linearity in the first argument. So obviously satisfy that is the Euclidean space R power n. Second example, that there is a complex Euclidean space C power n. இதை எப்படி டிஃபைன் பண்ணுறோம்னு பார்த்தீங்கன்னா, there is a C power vector space C power n with inner product defined as summation xk yk bar. Yk bar is the conjugate of the yk. So and summation k equal to 1 to n. முன்னாடி டிஃபைன் பண்ண மாதிரி தான் அங்கே எல்லாமே x1 y1 plus x2 y2 like this இருந்தது. இங்கே xk yk bar. Yk bar denote the complex conjugate of yk. This is also inner product. Inner product of something, that is x comma y is obviously is equivalent to y comma x bar, and x comma y equal to 0, then x comma x equal to 0, then x equal to 0, like this all properties satisfied. And space of continuous function, that is example, another example for the set of all continuous function on a comma b. How to define the inner product for this one? F comma g equal to integral a to b. This is a continuous function. Integral a to b f of x g of x dx. F of x into g of x dx. So c of a comma b, the inner product is an inner product space over R. And the sequence space L2. Sequence space L2 means L2 space that is defined as the collection of the sequence with the condition summation mod of x n square less than infinity with the inner product. Okay, inner product space over C, and matrix space Mn of R, that is n by n real matrices, the entries are real, form a inner product space with the condition, that is the inner product of A comma B defined as trace of A transpose into B, transpose of A into B. So trace of A transpose into B denotes the sum of the diagonal elements of transpose of A into B. Okay, am I correct? So this is the matrix space. This is the example for the another example for the inner product space. Actually, this is the standard example in the STIN book. That is the standard inner product on F power n. In F power n, define the U equal to alpha 1, alpha 2, alpha n, V equal to beta 1, beta 2, beta n. The inner product is defined as in general in the field of n dimension. So that is alpha 1, beta 1 bar. This general field கொடுத்துட்டாங்க. இது R இருக்கலாம், C இருக்கலாம். So alpha 1, beta 1 bar plus alpha 2, beta 2 bar plus and so on alpha n, beta n bar. So this defines the inner product on F power n. So suppose F equal to R on this reduces to the dot product. That means alpha 1 beta 1 plus alpha 2 beta 2 plus and so on alpha n beta n. Non-standard inner product on F2. F2 define the U equal to alpha 1 alpha 2, V equal to beta 1 beta 2. So U comma V inner product defined as non-standard. This is the standard. And non-standard 2 into alpha 1 beta 1 bar plus alpha 1 beta 2 bar, alpha 2 beta 1 bar, alpha 2 beta 2 bar. So it is easy to verify that this defines an inner product on F2. Inner product on F2. So the first property U comma V, that is inner product of U comma V equal to V comma U whole bar. So when you apply here, that is that equivalent to U comma V. Okay. That is a 2 alpha 1 bar, beta 1 double bar, that is V comma U. When you find out the V comma U, that is what is that V comma U? So when you take it 2 beta 1 alpha 1 bar and beta 2 alpha 1 bar plus beta 1 alpha 2 bar like this and beta 2 alpha 2 bar. So when you take the bar here V comma U bar, that is obviously equivalent to U comma V, and U comma V is obviously greater than equal to 0. In the case of U comma V equal to 0, that is U equal to 0, and linearity in the first argument is always equal. Okay, it's a very simple proof, not a difficult one. And another example in the STIN book, that is the L2 inner product on a function space. L2 inner product on the function space. And on the function space, let V be the set of all continuous complex valued function on the closed unit interval 0, 1. We will set of all continuous function, complex valued function on the closed unit interval 0, 1. Suppose f of t and g of t belongs to V. V is another set of all continuous complex valued function on the closed unit interval 0, 1. Now inner product of f of t, g of t, how to define integral 0 to 1 f of t into g of t whole bar dt. So this is the inner product on V. Easily verified the three properties. And another very important definition, norm. How to define the norm? That is for any vector V, the length of V is called the norm of V. Norm means the length. Length of V is called the norm of V, that is written as norm of V. Norm of V equal to square root of inner product of V comma V. Square root of inner product of V comma V is called the norm of V. That is a very important definition. First நாம் பார்த்தது inner product definition, and this is called that norm. So the for any, it's a result for any two vector in VV, alpha comma beta belongs to F, and the alpha u plus beta v comma alpha u plus beta v, how to define the, when you multiply it, the alpha into alpha, that is alpha bar nu vandrum, that is mod of alpha square u comma v, inner product of u comma v, and beta v into alpha u, that is beta u alpha, that is alpha bar beta, that is when you multiply these two, this is alpha bar beta v comma u, and I thought this is alpha beta bar when you multiply these two, sorry, this is alpha beta bar u comma v, alpha beta bar u comma v, and finally beta into beta mod beta into beta bar is called mod beta square. So mod beta square v comma v, this is the inner product of v comma v. This is a very simple idea. Okay, so the same way the corollary for any alpha belongs to F and u belongs to V, norm of alpha u equal to mod of alpha into norm u, mod of alpha into norm u. Okay, and this is called the squares inequality. If you take any three real numbers A, B, C, or real numbers such that a greater than 0, a lambda square plus 2b lambda plus c greater than equal to 0 for all real number lambda, then b square less than or equal to ac, b square less than or equal to ac, and a lambda square plus 2b lambda, abc into the real number, a into the positive, the quadratic in lambda should be greater than or equal to 0 for all real number lambda, then b square less than or equal to ac. That is, this is the quadratic equation in lambda. So when you 1 by a times this is a lambda plus b whole square, this has become the a square lambda square. So complete square method try pandrom, that's the idea. So inge a square lambda square vandha, that is complete lambda square apply panna mudiyum. So that a lambda plus b whole square means inge 2ab varum, inge b square venum illaya. So 1 by a times a lambda plus b whole square plus inge c irukku, idhula vandha actually b square by a venum, so minus b square by a. So non-negative, this is the sense, this is non-negative, already given that this is non-negative. So for all lambda, that is lambda equal to should be minus b by a. For lambda equal to minus b by a, lambda equal to minus b by a, this is c minus b square by a should be greater than equal to 0. So that means the right hand side kondu ponanga, that is we get it b square less than or equal to ac, b square less than or equal to ac. And squares inequality theorem, that is this is called the squares inequality. If u comma v for any two vector u comma v belongs to v, then mod of u comma v is less than or equal to norm of u norm of v. That is very important. This is the squares inequality. I'll skip the proof. And Euclidean space v equal to f power n with the standard inner product alpha 1 beta 1 bar plus and so on alpha n beta n bar mod square less than or equal to mod of alpha 1 square plus and so on mod of alpha n square into mod of beta 1 square plus and so on mod of beta n square. And another one, function space, that is v is the continuous function on 0 comma 1, that is inner product defined as integral 0 to 1 f of t g of t bar into dt. This is a standard form of the inner product over the function. So then mod of integral 0 to 1 f of t g of t bar dt whole square less than or equal to 0 to 1 mod f t square dt into 0 to 1 mod gt square dt. The squares inequality has important geometric meaning, that is in r power n, say that in r power n this is the squares inequality, that is which implies u dot v, that is mod of a is always lies between less than or equal to something x now, that is minus x less than or equal to a less than or equal to plus x. When you apply here for this inner product u comma v, u dot v, so minus of mod norm u norm v less than or equal to u dot v less than or equal to norm u norm v. When you divided by norm u norm v, we get it this one, minus 1 less than or equal to u dot v divided by norm u norm v less than or equal to 1. So the value of this one is always lies between the minus 1 and the plus 1 in the case of r power n, in r power n. And for the function it gives the bound on the correlation. Okay, for functions it gives the bound on the correlation between the two functions. And equality is true if and only if the vectors linearly dependent. Linearly dependent. And another very important concept, orthogonality and orthonormal sets. And orthogonality means that is u comma v for any two vector u comma v, u is said to be orthogonal to v. That means if the inner product of the u comma v equal to 0, inner product of u comma v equal to 0, then the u is said to be v, orthogonal to v. So the relation is symmetric, that is if u is orthogonal to v, v is orthogonal to u. Because of this is the inner product definition, v comma u equal to u comma v whole bar. So v comma u equal to 0 means u comma v equal to 0 means 0 bar nondrom. 0 bar na, that is equal to 0. So by the property of the inner product space, this is u is orthogonal to v, v is orthogonal to v, that is symmetric relation is true. Okay, but the orthogonal relation is symmetric. And orthogonal complement, that is very important definition. So w is surface of v, the orthogonal complement of w is denoted as w power the perpendicular symbol poduvanga, that is orthogonal complement of w, this is orthogonal complement of w is nothing but the collection of the vector space v, the collection of vector space v. எந்த மாதிரி எலமெண்ட்லாம் நம்ம கலெக்ட் பண்ணோம்னா, இந்த இன்னர் ப்ராடக்ட் ஆஃப் தட் எலமெண்ட், inner product of that element and the element of w should be equal to 0. இந்த v ல இருக்கிற எந்த எலமெண்ட்லாம் w ல இருக்கிற எலமெண்ட் கூட inner product 0 ஆகுதோ, அந்த collection of the vector space v is called the orthogonal complement of w. W should be the surface of v. W should be the surface of v. Wன்றது surface நமக்கு தெரியும். Orthogonal complement is surface னா நமக்கு we know the definition. So what is the definition? That is the linearity verified. Okay, and closure and scalar multiplication should be verified for the surface. So orthogonal complement is surface. எப்படின்னா for any two element நாம் எடுக்கிறோம் orthogonal complementல அப்படின்னா that is A is orthogonal to the point of W equal to 0. Inner product of the A and the point of W should be equal to 0. That is orthogonal complement. And alpha beta belongs to F. For any W belongs to W and alpha A plus beta B comma W equal to alpha times A comma W and beta times B comma W. So alpha times into 0 plus beta times 0, because of this is 0, because of A comma B belongs to orthogonal complement of W. So we get it, this is equal to 0. From this, what is the conclusion? The first one should be belongs to orthogonal complement. So what is the conclusion? The orthogonal complement is a surface. So very simple proof. Okay, surface proof பண்றது. Surface ன்றது உங்களுக்கு ஸ்பெசிஃபிக்கா சிலபஸ்ல இல்லனாலும் அதுக்காக தான் பார்த்தது. Okay, the orthogonal complement we can prove the surface proof பண்ண சொல்லலாம். இல்ல surface on கேட்கலாம். Okay, பேசிக்கா நமக்கு தெரியாம நம்ம எதுவும் proceed பண்ண முடியாது. So W intersection orthogonal complement of W should be 0, equal to 0, because of if W belongs to this one நம்ம எடுத்தா inner product of W and W equal to 0. W ன்றது இதுலயும் இருக்கு இதுலயும் இருக்கு இல்லையா? So that inner product of W comma W equal to 0. So that means both are, since W belongs to something, so intersection of these two is 0. Okay, positive definites of the inner product, that is implies W equal to 0. W equal to 0 means intersection should be equal to 0. And another very important definition, orthonormal set. Orthogonal பார்த்தோம், that is orthonormal set, and orthogonal complement பார்த்தோம். This is the orthonormal set. How to define the orthonormal set? The set of vectors Vi, in V, each Vi has a length 1, norm of Vi equal to 1, and another property, the distinct element of V, the inner product of distinct element of V should be equal to 0. That is, for I is not equal to J, Vi is orthogonal to Vj. That is, the inner product of Vi comma Vj equal to 0. So in the ரெண்டு properties satisfy பண்ணுச்சுனா, that is called inner product of the same element 1 இருக்கணும், inner product of different element 0 இருந்ததுனா, that is the collection, the set of vectors in V is called the orthonormal set அப்படினு சொல்லுவோம். Okay, so then V1, V2, Vn is an orthonormal set, then the vectors are linearly independent அப்படினு சொல்லலாம். ஒரு collection of vector is orthonormal set na, the vectors are linearly independent சொல்லலாம். And W equal to the linear product of linear combination of the vector with some scalar, that is alpha 1, alpha 2, alpha n. If W equal to like this, இது மாதிரி linear combination நம்மளால எழுத முடியுதுன்னா, each double alpha I should be the inner product of W comma Vi இருக்கும். Inner product of W comma Vi for each I. So this is also very important one. The first one is the very easiest one, linearly independent, because of suppose this is equal to 0 for any fixed I, the inner product when you with Vi, so when you take it, this is equal to 0 already, 0 comma Vi equal to 0. So this is equal to 0 means the left hand side, that is alpha 1 V1 comma Vi, V2 comma Vi, Vn comma Vi equal to 0. So Vj comma Vi equal to 0, for j is not, Vi comma Vi equal to 1. So this is implies each alpha I should be equal to 0. Each alpha I should be equal to 0. So therefore this is the linearly independent. And for the another one, alpha equal to omega equal to the linear combination of alpha 1 V1 plus alpha 2 V2 alpha n Vn for each I. the inner product of w comma vi, w ன்றது this is comma vi, so once again we get this one, so alpha I vi comma vi equal to alpha I நமக்கு தெரியும். So this is what about the other one, others are 0, so this is equal to alpha I equal to w omega comma vi ன்னு எழுதலாம். Sorry, w comma vi, yeah, w comma vi ன்னு எழுதலாம். So each and every alpha I we can express inner product of w comma vi. In the case of w equal to the linear combination of the sum. And another one, this is orthonormal set. Once again, the collection is the orthonormal set in V, and W belongs to V. Then the vector U equal to W minus inner product of W comma V1 into V1 minus inner product W comma V2 into V2 minus and so on minus inner product W comma Vn into Vn is orthogonal to each of V1, V2, Vn. Is orthogonal. Which one is orthogonal? U is orthogonal. Orthogonal to each of U, V1, V2, Vn. So when you try to compute the U comma Vi, so U on the inner product operate பண்ணீங்கன்னா இது கூட, so what you get it, Vi U comma Vi கண்டுபிடிச்சிங்கன்னா, that is U is nothing but this one comma Vi அப்படின்னா W comma Vi வந்துரும். இங்கே W comma V1 already there, V1 comma V1 வந்து V1 comma Vi வந்துரும். இங்கே V2 comma Vi வந்துரும் corresponding to this one. இந்த portion அப்படியே இருக்கும். So like this இதை ஆப்ரேட் பண்ணிங்கன்னா இங்கே வந்து பார்த்தீங்கன்னா Vi comma Vi is 1, otherwise 0. So W comma Vi into Vi comma Vi மட்டும்தான் இருக்கும். So otherwise 0. and W comma Vi இங்கே இருக்குது. Vi comma Vi என்றது 1 ஆகிடும். ஸோ ரெண்டு சேமாக இருக்கிறதுனால 0 ஆகிடும். ஸோ this structure of U, vector U is orthogonal to each V1, V2, Vn. எப்போனா the collection V1, V2, Vn is orthonormal set on in V இருந்ததுன்னா, orthonormal set in V இருந்ததுன்னா the U னுடைய structure is always orthogonal to each of the V1, V2, Vn. இதெல்லாம் மெமரைஸ் பண்ண முடியாது, பட் ப்ரூவ் பண்ணலாம். அண்ட் திஸ் இஸ் கால்ட் த ஆர்த்தோகனல் ப்ரொஜெக்ஷன் ஆஃப் W. Okay, this collection is called the orthogonal projection of W onto the surface spanned by V1, V2, Vn. The vector U is the residual ன்னு சொல்லுவாங்க, is the residual or the component of W orthogonal to the surface. And that this decomposition is a fundamental in many applications. W equal to the something எழுதுறது, this is called the projection, and this U is called the orthogonal component. Okay, I'll leave it. And example is the sample basis in R power n. Standard basis is the R power n, that is called E1 equal to 100. This is the standard basis. Okay, this one வருது எழுதுறது, the first one and the second position one and the nth position one form an orthonormal set in R power n with a dot product. So if you take any vector that is orthonormal set for any vector W, okay, and we have the W comma Ei equal to Wi. Am I correct? W comma Ei is Wi. So and what about the other properties? That is called the same element, the Wi comma W comma Ei என்றது is called the Vi. So இது ஆத்தரம்னா Ei comma Ei என்றது, that is inner product of Ei comma Ei should be equal to 1, and Ei comma Ej should be equal to 0. So எந்த ஒரு ஸ்டாண்டர்ட் பேசிஸ் that is orthonormal set எடுத்தீங்கனாலும், that is for any vector for any vector, the vector comma that something inner product of VI should be equal to WI. So that means which are exactly the coordinates of W in the standard base. அதே மாதிரி நாம்ன்றது coordinates are easily via inner product, that is norm components simplify, that is norm of alpha 1 v1 plus and so on alpha n vn equal to 0, mod alpha 1 square plus and so on mod alpha n square, mod alpha to square and so on for the norm. And orthonormal basis, its orthonormal basis and orthogonal decomposition. இது வந்து காலேஜ் டிஆர்பியில் இருக்க orthonormal basis ன்றது. So what do you mean the orthonormal basis means? The existence of orthonormal basis, V be a finite dimensional inner product space, finite dimensional inner product space, and V as an orthonormal set, V as an orthonormal set as a basis, V as a orthonormal set as a basis. Okay, well, that is called the and the construction of a Gram-Schmidt's orthogonalization process. Suppose V1, V2, Vn under the of V, construct a orthonormal basis W1, W2, Wn. That is the process of Gram-Schmidt's orthogonalization process. The first vector W1 under the V1 by norm of V1. For k equal to 2, 3, n, I will compute the projection of Vk onto the span of previous vector, that is uk equal to Vk minus summation I equal to 1 to k minus 1 Vk comma Wi, inner product of Vk comma Wi and into Wi. So the Wk is uk divided by norm of uk from this. So normalize, that is resulting W1, W2, Wn is an orthonormal basis. Orthonormal basis. And example pathina polynomial space with L2 inner product, that is f equal to r. The field is a real number. V be the space of polynomials of degree less than or equal to 2 with the inner product. The p of x comma q of x integral minus 1 to 1 p of x into q of x into dx equal to. So this is the definition for the inner product. And starting with the basis v1 equal to 1, v2 equal to x, v3 equal to x square. This is because of polynomial of degree less than or equal to 2 untradhanala. So this is the basis 1x x square. I will start with the norm v1. What is the definition of the norm v1? Integral minus 1 to 1 1 square v1 என்றது 1 தான், 1 into 1, that is so inner product of 1 comma 1. So that is 1 square into dx, that is equal to a dx na x nu vandurum, x na 1 minus of minus 1, that is equal to 2. So norm of v1 equal to root 2 nu vandurum. And w1, how to construct the w1? v1 by norm of v1, that is 1 by root 2, 1 by root 2. So the same way we can construct the v2 comma w2 கண்டுபிடிக்கணும். So that is orthogonalize v2 against w1, that is v2 inner product of v2 comma w1. v2 ன்றது நமக்கு x, w1 இப்போதான் கண்டுபிடிச்சோம் 1 by root 2. ரெண்டுத்தையும் மல்டி பண்ணிங்கன்னா that is 1 by root 2 வெளியே எடுத்துடலாம், that is x. x இன்டெகிரேட் பண்ண x square by 2, x square by 2 லிமிட் போட்டிங்கன்னா that is 1 by root 2 already வெளியில் இருக்கு, லிமிட் minus 1 to 1. Okay, that is upper limit lower limit 0. இல்ல ரொம்ப சிம்பிளா கான்செப்ட் அப்ளை பண்ண, this is the odd function. Odd function, the limit in the form of the minus a to a na, that is integral value is 0. Okay. So the same way u2 equal to v2 minus, by the definition, how to construct the u2? v2 minus inner product of v2 comma u1 into w1, sorry, inner product of v2 comma w1 into w1. So what is the V2? V2 is x minus inner product of V2 comma W1 is 0, 0 into 1 by root 2, that is equal to x. Okay. நமக்கு என்ன வேணும்? W2 வேணும். W2ன்றது U2 by norm of U2. So then what is the norm of U2? Norm of U2 means this is a x. So norm of U2 means x into x. So that is x square. So in x square integral limit minus 1 to 1 dx. So இதை limit போட்டீங்கன்னா there is a even function. Even functionன்றதுனால 0 ஆகாது. So 2 times 0 to 1 x square dx ஒன்றா போடலாம். போட்டுட்டு லிமிட் அப்ளை பண்ணிங்கன்னா that is x cube by 3. ஆல்ரெடி வெளியில் 2 இருக்குது. ஸோ 0 to 1 அப்பர் லிமிட் 1னா 1 by 3. ஸோ 2 by 3ன்னு வரும். ஸோ norm of u2 square equal to the something, norm of u2 equal to root of 2 by 3. So w2 construct as u2 by norm of u2, that is root of 2 by 3, root of 3 by 2x. So the same way we can construct the w3. எப்படி? The v3ன்றத inner product with the w1, v3ன்றத inner product with w2, ஏன்னா w2 கண்டுபிடிச்சிட்டோம். இந்த ரெண்டு வேல்யூவும் கண்டுபிடிச்ச பிறகு இங்கே பார்த்தீங்கன்னா எக்ஸ் ஸ்கொயர் வருது, ஈவன் ஃபங்க்ஷன். இப்போ முன்னாடி போட்டோம் அதே மாதிரி தான் 2 by 3. இதை அடிச்சிங்கன்னா தட் இஸ் ரூட் 2 by 3. இட்ஸ் ஓகே. இன்னர் ப்ராடக்ட் ஆஃப் v3 கமா w2, v3ன்றது எக்ஸ் ஸ்கொயர், w2ன்றது இப்போ தான் கண்டுபிடிச்சோம் ரூட் 3 by 2x. ஸோ எக்ஸ் இன்ட்டு எக்ஸ் ஸ்கொயர் எக்ஸ் கியூப். எக்ஸ் கியூப்னா ஆட் ஃபங்க்ஷன். ஆட் ஃபங்க்ஷன் இந்த இன்டர்வல் -1 to 1, இன்டெக்ரல் -1 to 1னா 0, அதனால் டைரெக்டாக 0 போட்டுடலாம். ஸோ u3ன்றது v3 மைனஸ் இன்னர் ப்ராடக்ட் ஆஃப் v3 கமா w1 இன்ட்டு w1 மைனஸ் v3 கமா w2 இன்ட்டு w2. ஸோ v3ன்றது நமக்கு என்ன தெரியும்? எக்ஸ் ஸ்கொயர் மைனஸ் இதனுடைய வேல்யூ ரூட் 2 by 3 இன்ட்டு w1ன்றது 1 by root 2. இது 0 ஆகிடுச்சு. ஸோ உங்களுக்கு கிடைக்கிற அவுட்புட் பார்த்தீங்கன்னா எக்ஸ் ஸ்கொயர் மைனஸ் 1 by 3ன்னு வருது. ஓகேவா? ஸோ நார்ம் ஆஃப் v3 u3 ஸ்கொயர் கண்டுபிடிச்சிங்கன்னா எக்ஸ் ஸ்கொயர் மைனஸ் 1 by 3 ஹோல் ஸ்கொயர் வரும். ஸோ டைரெக்டாக இன்டெகிரேட் பண்ணாலும் சரி, இது மாதிரி எக்ஸ்பெரிமெண்ட் பண்ணிட்டு இன்டெகிரேட் பண்ணிங்கனாலும் சரி. எக்ஸ்பெரிமெண்ட் பண்ணிட்டு இன்டெகிரேட் பண்ணும்போது இங்கே எல்லாமே ஈவன் ஃபங்க்ஷன். ஸோ ட்வைஸ் ஆஃப் 0 to 1 அப்படின்னு போட்டுட்டு ஓகேவா இன்டெகிரேட் பண்ணிவிட்டு 0 to 1 லிமிட்டும் போடலாம். இல்லை அப்படியே இன்டெகிரேட் பண்ணிவிட்டு -1 to 1 லிமிட் போட்டோம் ப்ரொசீட் பண்ணலாம். we get the 8 by 45. ஸோ norm of u3ன்றது root of 8 by 45. ஸோ இது 4 2s are 8, 2 root 2ன்னு வந்துடும். இது 9 5s are 45, 3 root 5ன்னு வரும். ஸோ உங்களுக்கு கிடைக்கிற அவுட்புட் பார்த்தீங்கன்னா u3ன்றது இதுதான். ஸோ we can construct easily w3. w3ன்றது u3 by norm of u3. ஸோ this is w3. ஸோ w3 construct பண்ண பிறகு we can write the orthonormal basis. What is orthonormal basis? w1, w2, w3. So this is a very important problem. ஏன்னா ஆர்த்தோனார்மல் பேசிஸ்ன்றது உங்களுக்கு ஸ்பெஷலாகவே உங்களுடைய சிலபஸில் இருக்குது, காலேஜ் டிஆர்பி சிலபஸில். அண்ட் ஆர்த்தோகனல் டீகாம்போசிஷன் தியரம். அண்ட் V is a finite dimensional inner product space, and Vன்றது finite dimensional inner product space. W is a surface of V. Wன்றது surface of V. V equal to W plus orthogonal complement of W. V equal to W plus orthogonal complement of W. More precisely, V is the direct sum of W and orthogonal complement of W. So, எப்போ Vன்றது finite dimensional inner product space இருந்து Wன்றது surface of V இருந்ததுன்னா Vன்றது V plus orthogonal complement of Wன்னு எழுதலாம். And particularly V is the direct sum of W and the orthogonal complement of W ன்னு எழுதலாம். It's a very simple proof. So what do you mean the orthogonal complement? That is the W intersection W complement should be 0, and so from this V equal to W plus direct sum of W plus W and W orthogonal complement of W. And another properties of the orthogonal complement is a very important one. In the case of the V is a finite dimensional inner product space, W is a surface of V, the double orthogonal complement. Orthogonal complement of W is should be equivalent to W. It's a very important one. And orthogonal projection of orthogonal decomposition is like this: direct sum of W and orthogonal complement of W. That means every vector V in V can be uniquely written as V equal to W plus orthogonal complement of W. W is belongs to W, W complement of W belongs to complement of orthogonal complement of W. So this W is the orthogonal projection of V onto W. Okay. And orthogonal complement of W is the component of V orthogonal to W, and the decomposition minimizes the distance from V to W, and this is called the least square approximation. The projection VW over the W is the best approximation to V from W. And Fourier series for the Gram-Schwartz process applied 1x x square and so on with L2 inner product space yields the Legendre polynomial, and decomposes signals into the orthogonal complements in the signal processing, and statistics orthogonal decomposition appears in the analysis of variance. And F is the real field, and V is F power 3. Then Squart's inequality implies that the cosine of an angle is absolute value. Cosine of angle is of absolute value at most 1. ஸோ இங்கே பார்த்தீங்கன்னா எஃப்ன்றது ரியல் ஃபீல்டுன்னு கொடுத்துருக்காங்க. ரியல் ஃபீல்டு அண்ட் வி இஸ் வெக்டார் ஸ்பேஸ் வி இஸ் எஃப் பவர் 3ன்னு கொடுத்துருக்காங்க. ஆக்சுவலி வாட் இஸ் த ரிசல்ட்னு பார்த்தீங்கன்னா ஸ்குவாட்ஸ் இன்இக்வாலிட்டி இம்ப்ளைஸ் the cosine of angle is of absolute value at most 1. So V is R cube. What is with the standard inner product? That means 1 0 0 0 1 0 like that, 0 0 1. The inner product of U comma V is U dot V, that is inner product because of R cube. And the Squart's inequality, what is the Squart's inequality? This is called the Squart's inequality. In R cube, we define the angle theta between the vectors U and V. How to define the inner theta? That is cos theta equal to U dot V divided by mod of U mod of V in podum. That is norm U norm V here. So the U is both are non-zero vector. From the Squart's inequality already proved that this lies between the -1 and the +1. Already பார்த்தோம். That is same idea. So from the Squart's inequality, this is left hand side கொண்டு வந்தீங்கன்னா this is less than or equal to 1. So modulus of this one less than or equal to 1. Modulus of this one less than or equal to 1 means cos theta is the 1. Mod of cos theta less than or equal to 1. That is implies cosine of angle between any two non-zero vectors as absolute value at most 1. As absolute value absolute 1 at most 1. Therefore, the Squart's inequality implies the something. So that means Squart's inequality ensures our geometric intuition about angles in Euclidean space is mathematically consistent. Without this inequality, we could potentially get mod of cos theta greater than 1. Okay, that which would violate the geometric meaning of the cosine. another one, f is the real field, f is the real field, then find 4 tuples of real numbers a, b, c, d such that u equal to alpha 1, alpha 2, v equal to beta 1, beta 2, which is both are belongs to f2, and inner product of u comma v, how to define the inner product is alpha alpha 1 beta 1 b a alpha 1 beta 1, b a alpha 2 beta 2, c alpha 1 beta 2, and d alpha 2 beta 1. So the inner product on f2, which is defined as the inner product on f2. So now we will try to find out the all 4 tuples, that is a, b, c, d. So that determine the condition on a, b, c, d such that the given bilinear form satisfy the inner product axioms. So the first of all, since f equal to r, real field, so the symmetry u comma v equal to v comma u. அப்படின்னா u comma v என்னன்னு தெரியும், v comma u என்னன்னு தெரியும். So u comma v என்னன்னு தெரியும், அதுலேருந்து v comma u கண்டுபிடிச்சிடலாம். Okay, that is the beta 1 alpha 1 like that. So from this to equal to for all u comma v, that is a equal to a, b equal to b, c equal to d, and so beta 2 alpha 1, this is alpha 2 beta 1. So c equal to d and d equal to c, correct? D equal to c. Okay, well, so the symmetry condition gives c equal to d. Okay, and another positive definiteness, ரெண்டாவது property, positive definiteness என்ன சொல்லுதுன்னா, for any vector u equal to alpha 1 alpha 2 is not equal to 0, inner product of u comma u, how to find the inner product of u comma u? U under something definition, that is alpha 1 whole square, it is the same vector, not a different vector, b into alpha 2 square plus c into alpha 1 alpha 2 plus d into alpha 2 alpha 1. So a alpha 1 square plus b alpha 2 square, inga c and d, c plus d into alpha 1 alpha 2, this is should be greater than 0 because of since c equal to d, so c equal to 2c in போட்டுடலாம், இங்க 2c alpha 1 alpha 2, that is should be greater than 0, and the quadratic form, this is the quadratic form. Okay, quadratic form is positive definite if only if the alpha 1 square coefficient should be greater than 0 and ab minus c square greater than, that is b square minus ac in பார்த்தோம் இல்லையா. So in the quadratic is greater than 0 varudha, ax square plus bx plus c, so b square minus less than ac, so that is ab minus c square greater than 0 since c equal to d என்றதனால. So the condition ab minus c square greater than 0 comes from the fact that the quadratic form, this is positive definite if only if the corresponding matrix, what is the corresponding matrix of this quadratic form? A, b on the diagonal, that is c because of 2c, alpha 1 alpha 2 la. So this is alpha 1 alpha 2 alpha 1 alpha 2 alpha 1 square a alpha 2 square b, this is 2c என்றதனால cc ன்னு போறோம் as a positive principal mind, that is so from this the same way the axiom 3 பார்த்தீங்கன்னா linearity property, when you choose that u and v, w, that is the alpha lambda u plus mu v comma inner product with the w, that is lambda mu என்றது belongs to r, the field r. So that is lambda into u, that is a into u என்றது alpha 1 alpha 2, v என்றது beta 1 beta 2. So when you apply here lambda into u, that is lambda a alpha 1 comma lambda alpha 2, okay, mu v is mu beta 1 and comma mu beta 2. When you add this to lambda alpha 1 plus mu beta 1, am I correct? Lambda alpha 1 plus mu beta 1 comma lambda alpha 2 plus mu beta 2. So this is the idea. So when you add it to these two, comma inner product with the w, then we get it. When you simplify it, a into lambda alpha 1 plus mu beta 1 gamma 1, because of the w is the gamma 1 comma gamma 2, b into lambda alpha 2 plus mu beta 2 gamma 2 plus c into lambda alpha 1 and plus mu beta 1 and gamma 2. So when you simplify it, lambda into the structure and mu into the structure, this is called u comma w. By the definition, this is called v comma w. So the linearity hold automatically from the bilinear form. So the necessary and sufficient conditions are, what are the values of the a, b, c, d, the four tuples, find all four tuples value. The first condition, c equal to d. The second one, a greater than 0 and ab minus c square greater than 0. So these are conditions. So four tuple is of the form a, b, c, c with the condition a greater than 0, ab minus c square greater than 0. This is called four tuples value. Okay, like this you can construct. Just நாம என்ன பண்ணிருக்கோம், inner product space definition apply பண்ணிருக்கோம். Okay. And another problem, we define the distance of zeta of u comma v, define the distance zeta of u comma v from u to v by zeta of u comma v equal to norm of u minus v, norm of u minus v. d in கூட யூஸ் பண்ணலாம், distance of d of u comma v in கூட define பண்ணலாம், ஒன்றும் தப்பு கிடையாது. That is norm of u comma v, that is the definition is norm of distance of u and v is defined as norm of u minus v. That is this is a very important. In this case, that distance of u comma v is always greater than equal to 0, and the distance of u comma v equal to 0 na, that should be u equal to v. Distance of u comma v is always distance of v comma u, and a triangle inequality is true. Triangle inequality is true. And this is a very easily we can prove the norm of x equal to root of inner product of x comma x. Distance of u comma v is norm of u minus v. The first one, non-negativity and identity, that is distance of u comma v equal to norm. Norm is distance between the u and v. Distance, norm means distance, that is always positive. Norm is always non-negative. And in the case of u equal to v, u minus v equal to 0, that is distance of u comma v equal to 0 if and only if u equal to v. And distance of u comma v equal to 0, that is norm of u minus v equal to 0, that is norm of u comma v means inner product of u minus v and u minus v equal to 0. That means u minus v equal to 0, so u equal to v. So this is the if and only condition, that is true. And another one, symmetric property, norm of distance of u comma v, distance norm of u minus v, minus வெளிய எடுத்தீங்கன்னா that is minus 1 into வந்துரும், norm of minus 1 into the plus 1. So norm of minus mod of minus 1, that is the real number, அதனால norm of v minus u, so norm of u minus v equal to norm of v minus u. So distance of u comma v is always equivalent to distance of v comma u. And a triangle inequality is also true. When you, it's very easy. So u minus v equal to w subtract பண்ணி w add பண்ணிட்டு norm operate பண்ணீங்கன்னா we get the very simple proof. And another type of proof, this is the for the triangle inequality. That is called the metric space definition also. This is another very important one. The case of this is W1, W2, Wm is an orthonormal set. This is the collection of orthonormal set. Then summation mod of wi comma v whole square less than or equal to norm v square. Less than or equal to norm v square for any v belongs to v. இதுக்கு பேர் என்ன அப்படின்னு பார்த்தீங்கன்னா, this is called I thought Bessel inequality. This is called the Bessel inequality. I thought real analysis படிச்சிருந்தீங்கன்னா real analysisல வரும் இந்த orthonormal basis inner product space, the Bessel inequality la angiyum varum. And V is a finite dimensional and W1, W2, Wm are the orthonormal set in V such that the summation mod of inner product of W comma V whole square equal to norm V square. Then W1, W2, Wm must be basis. Okay, this is the orthonormal set and satisfy this condition. Then the collection is called, that orthonormal set collection is must be basis of V. Basis of V. And the dimension of V equal to n, and W1, W2, Wm are the orthonormal set in V. Then there exists a vector from Wm plus 1 to Wn such that the combine of this orthonormal set and there exists vector is an orthonormal set and basis of V. This is also very important. Okay. We use the Gram-Schmidt process and they extended something. So that is called the Parseval identity and problem 6 extension theorem. And this is V in V, the parallelogram law. What do you mean the parallelogram law? This is the norm of U plus V whole square, norm of U minus V whole square equal to 2 times norm of U square plus norm of V square. It's a very easy proof, but the statement is this is called the parallelogram law. So what is this means geometrically in this special case V equal to F3. F is the real field, but the inner product is the usual dot product. So F3 means in R power 3 the dot product considers the vector U and V as sides of the parallelogram. Then U plus V, U minus V, the diagonals of the parallelogram. In R power 3 this is the diagonals of the parallelogram. The sum of the squares of the length of the diagonals is equal to 2y is the sum of the squares of the sides, and the diagonals U plus V, the sides of length norm U norm V, diagonals have length something, the law states like that. That is the geometrical meaning. And V be the real function, V be the collection of real function, y equal to f of x. That function satisfies the d square y by dx square plus 9y equal to 0. Then V is two-dimensional real vector space. We want to try to prove V is a two-dimensional real vector space, and in V define the inner product y comma z as 0 to pi y z dx. Inner product of y comma z defined as integral 0 to pi y z dz. What is the orthonormal basis in V? What is the orthonormal basis in V? The first of all, the collection of the real functions satisfying this equation, differential equation. So when you try to find out the solution for this differential equation, that is auxiliary equation and the solution for the auxiliary equation, that is r equal to plus or minus 3i, that is purely imaginary. Then what is the solution? That is a cos 3x plus b sin 3x, only purely imaginary. So the v equal to the span of cos 3x sin 3x, v equal to this, therefore v equal to the span of cos 3x and sin 3x, and cos 3x sin 3x are linearly independent. Okay, they are not scalar multiples of each other, that is dimension of v equal to 2. Okay, and the base is cos 3x sin 3x. When you, that is v1 v2, norm of v1 square, norm of v2 square find up panala, cos square 3x 0 to 2 pi. So because of by the definition 1 plus cos, what is the formula? Cos square theta equal to 1 plus cos 2 theta whole divided by 2. இதை நீங்கள் இங்கே அப்ளை பண்ணிங்கன்னா 1 plus cos 6x whole divided by 2. கரெக்டாக? ஸோ இதில் பார்த்தீங்கன்னா only 0 to 2 pi limit, just 0 to pi. So by 2 வெளியே எடுத்துடலாம், that is 1 plus cos 2x. So 1 by 2 into 1 integrate பண்ணிங்கன்னா x, cos 2x integrate பண்ணால் plus sin 2x sin 6x divided by 6. Am I correct? Sin integrate பண்ணால் minus cos integrate பண்ணால் sin, that is 0 to pi. இதில் பார்த்தீங்கன்னா actually sin 6x becomes 0, upper and lower limit, because sin pi sin 0 is always 0, sin any integer into pi and sin 0 value 0, upper and lower limit 0. Only pi மட்டும் தான் இருக்குது, x மட்டும் தான் இருக்குது, x க்கு upper limit மட்டும் தான் exist ஆகும், so pi by 2 is the answer. The same way sin square something, இது வந்து same procedure தான், is also pi by 2. So w1, how to construct the w1? v1 by norm of u1. So norm of v1 is square root of pi by 2, so now v1 is cos 3x, so cos 3x by root 2 by pi cos 3x வந்துரும். So இதே மாதிரி orthogonal is v2 against w1, that is என்ன பண்ணணும், inner product of v2, w1 கண்டுபிடிக்கணும். v2ன்றது sin 3x, w1 இப்போ தான் கண்டுபிடிச்சோம், இது ரெண்டு ப்ராடக்டில் இருக்குது, இன்டெகிரேட் பண்ண முடியாது. ஸோ sin a cos b ஃபார்முலா அப்ளை பண்ணணும். ஸோ sin a cos a, sin a cos a, ஸோ sin 2a whole divided by 2. ஸோ அப்படின்னா இங்கே sin 6x whole divided by 2ன்னு வந்துடும். தூக்கி வெளியே போட்டிங்கன்னா இது இன்டெகிரேட் பண்ணிங்கன்னா minus cos 6x divided by 6ன்னு வரும். லிமிட் வந்து பார்த்தீங்கன்னா 0 to pi. Actually cos even number into pi வந்ததுன்னா plus 1, cos 0 வேல்யூவும் plus 1 தான். upper limit lower limit ரெண்டு சேமாக இருக்கிறதுனால 1 minus 1 0, அதனால the value is 0. Okay, so we can construct the v2, that is w2 எப்படின்னா v2 by norm of v2. so v2 is already orthogonal to w1, that is 0. So that is root of 2 by pi, v2 ன்றது sin 3x, norm of v2 is root of 2 by pi, already find out பண்ணிட்டோம். So this is the w2. So இதனுடைய orthonormal basis of v என்னன்னு பார்த்தீங்கன்னா root 2 by pi cos 3x, root 2 by pi sin 3x. This is the simple example how to construct the orthonormal basis of the some application problem. The same way, this is another problem. V be the set of real function y equal to f of x satisfying the d cube y by dx cube minus 6 d square y by dx square plus 11 dy by dx minus 6y equal to 0. இங்கே v ன்றது 3-dimensional real vector space. In v, define u comma v equal to integral minus infinity to 0 u v dx. And this defines an inner product on v and find an orthonormal basis for v. Orthonormal basis of v. So the characteristic equation is r cube the something, அதனுடைய solution கண்டுபிடிக்கலாம். So that is e power x, e power 3x, e power 2x. This is the span. V is span of this one. The functions are linearly independent because of Wronskian is non-zero. So the dimension of v equal to 3. Dimension of v is 3. So how to find out the dimension? That is the linearly independent solution is called the dimension. And inner product of u comma v, when you try to find out the u of x, v of x over the integral limit minus infinity 0 defines the inner product. So that is u comma v, and symmetric is true, positive definiteness is true, and linearity is true. Okay, and now find the orthonormal basis using that the gram squares process. Norm v1 square find up பண்ணுறோம், e power 2x தான், லிமிட் போட்டிங்கன்னா 1 by 2 வருது. w1 என்றது v1 by norm of v1, and v2 comma w1 inner product கண்டுபிடிக்கிறோம். So some answer u2 equal to v2 minus v2 comma w1 into w1. இந்த portion வந்து previous problem 0 வந்தது, இந்த இடத்துல we get the something. So new function, so norm u2 square கண்டுபிடிக்கலாம், and then W2 equal to U2 divided by norm U2. And the same way W3 கண்டுபிடிக்கணும்னா V3, W1 inner product, V3, W2 inner product ரெண்டு ஆன்சர் கண்டுபிடிச்ச பிறகு U3 என்றது V3 minus V3, inner product of V1, W1, W1 inner product of the V3, W2 into V2 and இதனுடைய ஆன்சர். So and then norm of U3 square கண்டுபிடிச்சிட்டு we can construct the W3. The W1, W2, W3 is called the orthonormal basis. Okay. And W is a surface of the V. V is belongs to V, satisfying the V, W and W, V less than or equal to inner product of W, W. For every W belongs to W. Then inner product of V, W equal to 0. V, W equal to 0 for every W belongs to V. The case of W is a surface of V and V belongs to V. Then this is less than or equal to something for all W belongs to V. W is a surface, and W belongs to W, then alpha W belongs to W. For any scalar, when you substitute here, this is less than or equal to something. Linearity and conjugate symmetry எடுத்தீங்கன்னா that is இந்த W alphaன்றது alphaன்னு வந்துடும் and alpha bar into W, V. Okay, conjugate and linearity and the conjugate symmetry, that is equal to mod of alpha square W, W. So that consider the two cases. Then V, W equal to 0. And this is the V is finite dimensional inner product space and F is a linear functional on V and then U0 belongs to V and U0 F of V equal to U, V0, V, U0. V is a finite dimensional inner product space and if F is a linear functional on V, the collection of linear functional on V, then there is a U0 belongs to V such that F of V equal to V, U0, inner product of V, U0 for all V belongs to V. This is also very important one, just catch the point. That is okay. I'll stop here. So very important concept, the inner product space. Okay, இன்னைக்கு நிறைய பார்த்துருக்கோம், நிறைய ப்ராப்ளமும் பார்த்துருக்கோம்.